Are we alone in the universe? When you look up at the stars, could it be by chance another civilized person is looking at you? This question has been accompanied by the development of astronomy. When we realize that the other planets in the solar system are also like the Earth in such a vast world. When we realize the stars are actually other solar times. When we realize many objects called nebulae. In fact, it is a galactic time similar to the Milky Way. We are constantly broadening our horizons, but we hit a hard limit. The edge of the observable universe, because the speed of light is finite, 300,000 kilometers per second, and the universe doesn't exist forever. It only existed for 13.8 billion years. Multiply these two numbers together. We get a boundary. Since the birth of the universe, light can only travel so far. So we can't see beyond this bound. Things beyond limits. Current estimate. The diameter of the observable universe is about 93 billion light years. That's right. That's more than double what it was in 13.8 billion. But this is because since the birth of the universe, it's been expanding. Beyond the objective universe, we can't be sure what happened there. Is the universe finite or infinite or flat? These problems can only be left for the future. As far as today is concerned, we just defined the scope of exploration. 93 billion light years. Within this range, we will explore whether life exists. Does intelligent life exist? And what are their proportions? It requires a lot of assumptions. Because of the stars, the populations of planets and galaxies remain unknown. Fortunately, this is a rapidly evolving field of research. Maybe in the next 10 to 2 years, we can see definitive evidence. Let's first define what we're looking for. The Earth is a rocky planet in the habitable age of a yellow dwarf star, and yellow dwarfs are stars like the Sun. Only based on these parameters, we can perform some interesting calculations. In the universe, the most common stars seem to be red dwarfs. These very small stars have extremely long lifetimes. This is about 73% of the total number of stars in the Milky Way galaxy, probably 73% of the total number of stars in the universe. According to our first definition, we'll talk about that later. Next up are stars like Genesis. The star is slightly larger than the infrared star. Lifespan is also slightly shorter. They don't fit our definition. But some researchers believe that they may be suitable for life to exist. So we will also pay attention to them. Adult dwarfs make up about 13% of the total number of stars in the Milky Way galaxy. Yellow dwarf, that is our first target. Number is third. About 6% of the total number of stars in the Milky Way. For every Sun-like star, there is a Chen dwarf and 12 red dwarfs. We can ignore more than these three categories. A star, a bigger star, because their lifespan is short. It is difficult for life to develop around them. According to the proportion determined, we can start making preliminary estimates first. From the perspective of the Milky Way galaxy, can't determine the accuracy of the entire galaxy, the number of stars. It could be anywhere from tens of billions to hundreds of billions. So we use that as a basis for our estimates. If the proportions given earlier are applied, this means that there could be 60 million people in the Milky Way galaxy, 1 minus 241 stars similar to the Sun. That's quite a lot. If they're not already occupied, it means that everyone can be divided into 1 to 3 yellow dwarfs. Star. We can't calculate how many yellow dwarfs there are in the real universe. So today, we will only discuss the Milky Way. The observable universe extends 93 billion light years, and our galaxy is only 100,000 light years across. So, we also need to do a lot of multiplication. It is estimated that there are approximately 200 billion stars in the observable universe alone. It's a little bit smaller than the Milky Way. Some are bigger than the Milky Way. Therefore, we need to 6 billion the galaxy to 24 billion. Number of yellow dwarfs. Multiply by 200 billion galaxies in the observable universe to understand the considerable. How many sun-like stars are there in the universe? If we were alone in the universe, then all these resources belong to humans. We don't have to worry about energy. Don't worry about crowding. Before that, we need to use a method to screen. Remove those that are not suitable. Actually, we are not interested in all these stars. Some of them are very young. They're potential planets. There is not enough time to develop. Some of them are older, about to leave savings. Their planetary systems are not in good shape, good state. It seems that the formation of most stars and planets very different from what we see in the solar system. We have discovered many thermite stars. They orbit the yellow dwarf. These massive planets are very far from their star. We are interested in those who have migrated to. Rocky planet within. Those giant gas planets. Excluded system. A study published in 2022 based on K observatory data conducted for us provides a number suitable for use here. 10% to 20% of sun-like stars. There may be a line that is the same as ours. Star system, we average this number below. Let's say 15% for the Milky Way. This means that there may be 900 million to 3.6 billion with us. Planetary system. Every such system may have at least one. There are up to 30 rocky planets in its transition zone. According to our previous ratio, we will have 1 billion planets. Meets our first definition of a galaxy. And of course, multiply that by 200 billion to cover the entire observable universe. Not all planets are likely to have a wide range, wide ocean, green grassland, and a habitable environment. Being on a livable lone doesn't mean being habitable. Just look at the moon. He's completely in the sun's habitable zone, like the Earth. But that doesn't make it a habitable planet. Despite this, we have a problem here. We don't know what exactly made the Earth with livable conditions. Is his size, the exact distance from the sun, his magnetic field, his chemical composition, or his massive satellite? Whether these elements must be strictly reproduced to create an environment like this on our planet. We also encountered observational astronomy here, the limitations of learning, not yet possible. Know exactly what a rock is. Does an exoplanet have a satellite, star, or magnetic field? So, we cannot estimate the proportion of truly habitable planets. However, there are strict screening criteria. A planet that meets all the conditions, the number will be greatly reduced. In the solar system, surrounding rock, large moons of rocky planets look rare. Only the Earth has one. The same is true for powerful magnetic fields. Venus is almost as big as Earth. He didn't. So is Mars, although Mercury is in the middle. Therefore, to recreate the exact conditions of the Earth, we may need to divide our sample by 10, even 1,000. Here's the good news, even though we are very strict in our division. But the number of planets to choose from is still huge. Only in the Milky Way, and there are millions of them out there. So much so that we asked Henry, just like Fermi said, life should flourish everywhere and should be able to be detected. There are dozens of ways to look at Fermi's theory. I have a chance to chat with you all. However, the reason why we keep, because some of these solutions, the solution may result in stricter filtering, like a time filter. If the solar system existed for 4.5 billion years, intelligent life has only been around for 4-5,000 years. If we only cared about intelligence, how long did life exist? That time period, millions of primordial objects in the Milky Way galaxy, planets that could have harbored life. Reduced to just a few, maybe not even one. In other words, Earth civilization in silver, ephemeral, insignificant on the timescale of galaxies. The range of the observable universe and galaxies, it's really expansive. If a civilization can only maintain for hundreds to thousands of years, and it's capable of electromagnetic communication, then he is most likely hundreds to thousands of light years. Other civilizations discovered, although many stars are involved. But with 100 billion to 400 billion stars in the Milky Way galaxy, compared to the total number of stars, that's a lot. Our purpose in finding Earth, like planets, is important. If it is possible to proceed with radio communication with extraterrestrial civilizations, then look for planets over 100-1,000 light years away. It doesn't make sense. Also, if it is for interstellar travel, we should also pay more attention. Planets within 5-10 light years, because even reaching the nearest Proxima Centauri system, it requires tremendous energy and effort. The number of possible objects in our observable universe, billion, even trillions of Earth-like planets. If every galaxy had at least one civilization, so there are at least 200 billion civilizations out there. But these civilizations and planets are too far away for us, unable to communicate or travel. We should focus on the planets that are closer to us. For example, planets within 50 light years. Within this range, we estimate there are about 500 like the Sun, such a yellow dwarf. About 100 of them may have classes, a planetary system similar to our own solar system. Although in these systems, discovering an intelligent civilization is unlikely, but find something that supports simple life, or with future colonists, the probability of a civilian planet is higher. Much before us, we're looking at stars that are similar to our Sun, but actually, Chen dwarfs and red dwarfs are more numerous. At a range of 50 light years, we found about 1,500 Chen dwarfs, stars, and 5,000 red dwarfs. These stars are relatively faint, so it's hard to detect from 10-20 light years away. For example, the IH's system is a system that contains red dwarfs, and the system of dwarfs, that's 22 light years away. It wasn't discovered until 2013. Many rocks have been found around these stars. Stone planet. The most notable of these is the TRAPPIST-1 system. It has 7 planets the size of Earth. 3 of them are located in the habitable zone. These stars are very stable. It is expected to last longer than the Sun. So within 100 light years, we have a lot of interesting planets to study. However, it's hard to determine whether these planets are really a play. Exoplanet. Red maze are some very faint stars. Their habitable zone is very close to the star. The planets that cause them to orbit, often one side is always facing the stars, like forever daylight. On the other side is the eternal black mark. In addition, infrared stars are prone to explosions. Planets in their habitable zone will receive 400 times more love than the Earth can ray. This makes us question, around infrared stars, are there really habitable planets? if we were near our solar system, found such a planet. So what about exoplanet? Estimation of quantity. It may increase by at least 10 times, if not. Then around the red dwarf star, there may be fewer habitable planets. Chen dwarf is located between a red dwarf and a yellow dwarf. They have a shorter lifespan than red dwarfs, but longer than a yellow dwarf. Chen dwarf-like habitable generation. It emits fewer X-rays than red dwarfs, but more than yellow dwarfs. That's about 25 times the size of the Earth. No processed dwarf. It emits less ultraviolet light than the Sun. This makes them become the ideal place to find life. This June, scientists have announced around a dwarf star 55 light-years away, 3 super-Earths have been discovered. One of them is in the habitable zone. The orbital period is 151 days. This means he may not be spinning in sync. Have an ideal day and night shift. If there really are 1,500 dwarfs near the solar system star, then we have a good chance of finding a real one, a habitable exoplanet. If such a planet, less than 10 light-years away, it might just be worth the investment. Huge effort to go on interstellar travel. Thanks for watching. Welcome to leave a message for discussion.